Hi there, my name is Blaise and this is my dissertation demo for my Creative Technologies project. My project is a study on the evolution of games meta and how optimal strategies are found between AI players. So what we have here is a simulation which is we've got defenders, which are these skeleton characters, we've got attackers, which are these knight characters, and we have a chest, which is the goal for the attacking players. So the attackers have to try and get to the chest, and the defenders have to stop the attackers by walking into them within 500 turns. So this simulation is an output from a machine learning algorithm, which is here, which is this Python script, which is using a Q-learning algorithm to represent to teach two models, an attacker model and a defender model, basically how to play the game by using by playing a bunch of parallel games all together, and then taking those games, adding them to short-term memory, which is then compared to long-term memory, which in turn creates the Q-loss function for this machine learning algorithm. And that Q-loss function is what teaches the future players exactly how to play the game and what strategies can be found through playtime. This machine learning algorithm also outputs a JSON file, which is what I'm using for the simulation in Unity. This represents the map, which currently is just zeros around the outside, which are the walls. But as the AI gets smarter and gets more robust with more strategies found, I'm going to be randomly generating the ones in here in order to make more of a complex challenge for the AI to tackle and get around. We have our players here, so we have two attackers and two defenders, and this can be increased or decreased, but currently I think that it's much better just to have the two on two. And back to our simulation, this is the main parts that I'd like to be able to show and demonstrate the strategies and the meta game of this game and how those have been found by the AI. So using this search bar, I'm able to type in, say, like 21 and show that simulation and see what was made, what was done, whether a strategy was found, what was it that was found, and was it derived from a previous generation just by viewing it. That's currently only what I can do by going through the iterations one by one. Say if I wanted to go to 27 and watch this game, I can do. But as more and more iterations of the algorithm is done, or the AIs is created, and more generations are made, I want to be able to map out on a graph that a player or a developer will be able to scan across and see whereabouts the wins and losses are coming from, and click onto that game, and it will show and demonstrate here in this sim exactly what it was, the strategy that was found at that point, or what the game was at that point, and show that playback in a way that people will be able to see where the metagame is forming and where those strategies are found. So hopefully, when this works, this will be a valid way of demonstrating metagames and strategies found using these AI players by using this simulation app. Thanks very much for watching. Yeah, cheers.